In our first take on completing the square, we were dealing with trinomials that had a values of 1 and b was even. If you can see the trinomial we're dealing with now, our a is a 2 and our b, a 5, is an odd number. We're going to be able to do this work, but it's going to require a little bit more heavy lifting to do so. Our first example challenges us to complete the square, which we've done in the past. The difference is now our b value is a 5. So the first thing we want to do is just take a look and make sure that we're in standard form, ax squared plus bx plus c, and we want to make sure that a equals 1. It does in this case, so we can proceed, but in the future we're going to have to deal with that. Now we want to complete the square like we have done in the past. So we want to be able to take half of our b value and square it. So assuming that a equals 1, c is going to be half of b squared. Our b value is 5, and when we square 5 halves, we come up with 25 fourths. So we express our trinomial as x squared plus 5x plus 25 fourths. Our next set of directions asks us to express this as the square of a binomial, so in step 3, it suggests that we should be able to do this through factoring. We should be able to set up two sets of parentheses, have x and x, and two plus signs because we want to multiply to get a positive and add to get a positive, and our value that goes in is going to be 5 halves. We can reverse directions, we can FOIL and see that this comes out to be true. But to finish up, we can express that as x plus 5 halves all squared. And just a reminder, how did we find c? We were asked to take half of b and square it, and half of b was 5 halves, and that's what comes in as our term at the ends of these parentheses. 5 halves plus 5 halves equals 5, and 5 halves times itself equals 25 fourths. So let's work for another example. Can we find the value of c that's going to make x squared minus 9x plus c a perfect square trinomial, and can we write it as an expression of the square of a binomial? So again, when we take a look at the standard form, we realize that we have an a value of 1, of b of negative 9, and we're looking to find c. We want to assure that a equals 1, and it does, so we're in good shape to proceed with finding c the way we have in the past. We take half of b and we square it. So we set ourselves up, what is the b? Negative 9, and half of negative 9 squared is 81 fourths. Notice the negative 9 is still going to be inside those parentheses. It's going to come into play in just a moment. Now we write our trinomial as x squared minus 9x plus 81 fourths. Part 2 of our directions ask us to write the expression as the square of a binomial, and we do so by factoring. So step 3, we're going to factor. We write our two sets of parentheses, x and x go at the front ends. We want to multiply to get a positive 81 fourths, and we want to add to get a negative 9. So we want to hold on to those negative signs. When we create the perfect square trinomial, we're always going to be adding something because a negative times a negative or a positive times a positive is always going to give us a positive. But when we come back to factoring, we've got to hold on to those negative values. And finally, when we write it as the expression as a square of a binomial, it's x minus 9 halves squared. In example 2, we also want to solve by completing the square, but if you notice, this time a does not equal 1. We have a 5 for our a value. In trying to do this, our first step is going to be to move the 15 to the right-hand side of the equation. So when we write that, we subtract 15, and we leave room because we know that we're going to try to create a perfect square trinomial. The other issue here is that the leading coefficient is no longer 1. A is not 1, but it's a 5. In order to complete the square, we want a to equal 1, so factor out that 5, and notice that that creates 1x squared plus 4x inside the parentheses. We haven't touched the right-hand side. That negative 15 still remains. Now, just like in earlier examples, we want to complete the square. In order to do so, remember we now have the ability to take half of b and square it. So half of 4 is 2, and 2 squared is 4. So we put a 4 inside the parentheses for c. Now we have to keep the balance of the equation, so it's tempting to think that we're going to take that 4 and put it to the other side of the equation. But wait, take a look at what's going on. 4 is inside the parentheses, so the balance is not necessarily that we put 4 on the left, but we actually put 5 times 4 on the left. So in order to complete the square properly and hold the balance of the equation, we have to put 4 inside the parentheses, but on the right-hand side, that's equivalent to 5 times 4, we need to put in a 20. For steps 4 and 5, we want to be able to factor that perfect square trinomial, and so we should get x plus 2 and x plus 2. We still have the 5 on the outside, and on the right-hand side we had negative 15 plus 20, so that simplifies to 5. If you notice that we have a 5 on both sides of the equation, it would make some sense at this point in step 6 to divide by 5 and express the square of a binomial, so we can write x plus 2 squared equals 1. In step 8, we want to take the square root of both sides, and so that's going to give us x plus 2 on the left and plus or minus the square root of 1 on the right. Finally, if we subtract 2 to the other side of the equation, we will come up with x equals negative 2 plus or minus 1, and if we want to write our final answer, we can say that we will have the values of negative 3 and positive 1. example 3, we want to take 2x squared plus 5x minus 3 and create a perfect square trinomial in order to solve. 3 is not the value of c that we normally would want, so our first step would be to move that to the other side of the equation. Also, in order for us to complete the square, we want to have our leading coefficient be a 1. That's the 1 that should be in front of the x squared, not 2. So we factor out the 2 on the left. When we do, that very nicely gives us a 1x squared, but unfortunately it gives us a 5/2 for our b. That's why this problem becomes a little bit more tedious. But we are in position now to complete the square. And remember, to do so, we need to take half of b and square it. 5/2 divided by 2 is equivalent to 5/4, and if we square 5/4, we come out to 25/16. So 25/16 is what goes in as our c value on the left. But remember, if we're going to try to balance the equation, we're going to have to add on the right. We've added on the left, we now have to add on the right. But what did we add? We added 25/16 times 2. Pay attention to the 2 on the outside. And so the value that actually goes in on the right is going to be 25/8. 25/16 times 2 reduces to 25/8. So now we're in a position to factor that perfect square trinomial, and that should leave us with x plus 5/4 twice. Everything else for the moment can remain the same. Now with this equation in step 6, we're ready to write this as the square of a binomial. That would be 2 times x plus 5/4 squared, and the right hand side still remains the same for the moment. But I want to pause here to just note that our goal is to be able to solve for x. We want to be able to say that x equals, and this was an important step because instead of having x written twice in the previous line, it's now only written once. You might see that on the left-hand side there's still the 2, the 5/4, and the square, so there's still some work to be done to get x by itself, but at least there's only one x written now. Moving over to the right-hand side, you see that we have 3 plus 25/8. So in steps 7 and 8, the first thing we want to do is find a common denominator. We want to be able to add and have 8 as our denominator. Once we do that, how does 3 become something over 8? We express that as 24/8. Now we're in a position to add, and we should come out to 49/8 over on the right. So 2 times x plus 5/4 squared equals 49/8. Our next step is to divide both sides by 2, and that should leave us with x plus 5/4 squared equals 49/16. We now have 2 steps to go because you can see we have x plus 5/4, we need to get rid of that, and we also have that expression squared. So the first thing we can do is take the square root of both sides. When we do that, we'll be left very nicely with x plus 5/4 on the left, and on the right, when we take the square root of 49/16, it leaves us with plus or minus 7/4. The only thing left to do is to subtract the negative 5/4 over onto the right. And that leaves us, remember, with the plus or minus, so there's 2 situations here. First, we can take negative 5/4 and add 7/4, come up to 2/4, which is 1/2. Or if we subtract, negative 5/4 minus 7/4 should give us negative 12/4, and negative 3 comes out as our second answer. Our 2 answers are negative 3 and 1/2. That last example took several steps to complete, and we have alternative methods, and sometimes our alternatives are better. So if we return back to 2x squared plus 5x minus 3, I want to suggest that that thing can factor very nicely and lead us very quickly to an answer of x equaling 1/2 or -3. In Algebra 1, you are introduced to the quadratic formula, and we'll be revisiting it very soon. If you take your values of a, b, and c and plug them in, simplify, you should also find out that x can equal 2/4 or -12/4, which reduces to 1/2 or -3. And if you have some graphing technology, whether that's a Texas Instrument 83 or 84, or Desmos, or just some old-fashioned graph paper, and just plug in some values when x equals -2, -1, 0, 1, 2, see what happens. You also can come upon your x-intercepts, which are our solutions. Completing the square is a good and important process, but there are alternatives that sometimes work even easier.